What is up, everybody, and welcome back to another episode of Beards and Gears. Today we have a different episode. Well, tonight, because it's nighttime, I got home from work and had to help my dad out with some stuff. Besides that, this is my Chase Bays Hydro. This thing has been on my car for a year or so, maybe less. Like, I don't drift on the street, so I only use this during the track events, and it broke. It broke during a test drive when I was just testing out if I bled the brakes, the dual calipers correctly or not. I contacted Chase Bays. Some of you might not know, I'm a mechanical engineering major. The second I looked into the brake itself, I can tell that it had a lot of issues. I'm going to put a picture up and kind of describe what I see. I see large granule structures, and I also see some like different colors, and I want to call them delaminations or layers within the actual metal. This can hint at either improper casting of the metal. It can hint at overheating during the machining process. And also there are a few other things that I noticed was there is a lot of side-to-side movement when you are pulling up on the e-brake, and that can cause forces to be distributed differently throughout the entire, throughout that actual point where all the pressure goes, because this is where it mounts to the actual master cylinder rod. That's the connection point.
I know what I'm doing. I'm an engineer.
To it. So today I'm going to kind of be doing something different where, you know, even though Chase Bays is sending me a brand new one, and when I emailed them and I told them all this stuff like, hey, this is what I'm seeing going on, you know, you could do X, Y, Z to correct this. They admitted their mistake and said, okay, we're sending you out a new unit, no questions asked. So Chase Bays has amazing customer support. There's without a shadow of a doubt of that. The only thing is, I kind of want to put my own spin on my own handbrake, and I am an engineering major. So it's about time I engineer car parts. And today I'm going to be showing you my method designing a handbrake for my car. So here's all the tools, save for a razor, I gotta find one, that I'm going to use to get started on this handbrake. Some cardboard, some tape, and a digital caliper for my measurements. And from this, I'm going to design a very rough template for the Hydro that I'm going to bring over into CAD. The program that I'll be using is SolidWorks. It's provided by my university, free of charge. It's a part of the tuition. And we're going to see if I can come up with something sick. Using my old Hydro as a template for my new one, which you will understand later why I'm doing this, we're just gonna get a rough idea of how things used to be and how we're gonna wanna make them. This is a very, very, very rough draft just to get an understanding of how things were and how we're gonna want them to be. So there we go. That is our original Hydro. I should mark where the old holes used to be. So this is where this old hole used to be, and this is where this old hole used to be. If we can just make a circle around there, kind of fill that one up. So that's where the old holes used to be. This is to master. This is pivot. That's the pivot. So from here, we can actually begin to understand how we want to get started with this design. Now, like I said, this is very rough. So first and foremost, I did not like how this sat in the car. I feel like this kind of sat a little too low, and I really had to reach for it down there. So first and foremost, we want this to come up. And we want these two spots where the holes are to stay the same. That means changing this angle. So with the power of some blue Scotch tape, I was able to tape everything back together, and now I can actually start taking my measurements. By using this is where engineers start to cheat. I had you all excited for that, using this, and then I just remembered, yo, I've got an angle finder, and they're pretty easy to use. So we're simply just gonna take this to find that angle and push it up against there. Now I have the bottom angle of my Hydro, and that reads to be, we'll call that, I don't know, let it focus, we'll call that 30 degrees. So now, the bottom of this angle, I want this to be up more, so that the angle of my approach for my hydro, can go from here to here. which is roughly 20 degrees. That now takes that bottom angle where it was before and will roughly place it up there. This will bring the entire hydro much higher in the car. This will bring the hydro much higher in the car. That way I have an easier time reaching for it. Before we go on from here, I know I'm going to make some mistakes. This is really the first time I've ever tried to design something on my own. The first time I designed something on my own was in CAD class. The second time I tried designing something on my own was actually, you know, after school. I designed a cup holder that I've yet to print out because it needs to be revisited. This time, we're kind of going full send in this thing. So I'm going to try to either 3D print this thing, or I'm going to utilize some virtual reality software that you can easily find anywhere. I'm pretty sure you can download them on your laptop. I know that HP comes with one that isn't the best, but that's enough for now. For now, we're gonna continue with this design. So now I know I wanna take this, and actually bring it up this way, all right? So what we're gonna simply do is I'm going to just get started on this. This is going to be my bottom now. And we're just gonna start layering it on. Huge shout out to Lowe's for the stick. And from here, we are going to go roughly 20 degrees. Match it up like that. This is the part where CAD kind of comes in handy. You can just match up angles like that. So now we have our old hydro and our new hydro, and you can see the difference between the angle. Whereas this one came pretty flat, this one is now coming at a much higher approach. All by changing the slightest angle of approach from here. And you can see, you know, in engineering school, when they tell you the slightest change in angle may not be apparent to begin with, but later down the line, that's when you begin to see the change. So now we're gonna move on with our design. We're gonna cut this out, and we're gonna see how it fits inside the car. So in order to add some structural rigidity to my CAD design, cardboard aided design, I decided to cut out a little, another little piece just to get a better idea, and then we're gonna tape these two together. So now here we are inside of the car, pretty tight space. What I'm going to do is I'm going to just attach this over here and over here, and we can even begin to see that it's sitting quite a bit higher. So let's bolt that in and see how it looks. So now we're all bolted in, and as you can see, we are much higher than where we used to be. Before, it used to sit down here, like literally almost parallel with the center console. And now we're sitting pretty high. And the great part is, this is bottomed out over here. So if I really needed to bring this down a little more, I could just by screwing this. And let's see how that looks when this is maxed all the way out. And this is how it sits when it's maxed out all the way down. You can even see, like, it is so much higher than where it would be if that angle was not changed. I mean, we have a change of about 10 degrees from that bottom angle down here. So now you're probably asking yourself, how am I going to beef up this? I noticed that it's relatively consistent, the width, throughout the entirety of the hydro. So what we're going to do is we're going to measure that edge to edge. We're going to call that 28.05 millimeters. We can safely assume that the bearings are centered in the actual hydro. So how much wider do I want to go? How much beefier do I want this to be? Well, before running any type of CAD simulations, I'm going to say I want to make this at least 29 millimeters plus or minus 0.05 millimeters. And that is literally a difference of that much. You can see there's like barely any room for that to really shake. 1 millimeter and some better material can make all the difference. Now we come to the bearing. We're gonna call the first one the master cylinder bearing. So my master cylinder bearing, I'm gonna call that 22.23 millimeters. The inside diameter of that is 8.75. So we've determined now that the inside of the pivot bearing and the inside and the outside of the master cylinder bearing are both exactly the same. So now we can say that master cylinder and pivot. The last measurement I want to take is this whole distance, the whole length of the hydro, and I'd like to extend it a few inches. And for that, I am just going to use my measurement tape, and that's it. That distance comes to about 17 inches. And with some magic, let's say we want to make a 17, 18, 19, 20, and even 20 inches, 2 millimeters. I'm gonna put 20 inches, that's 508 millimeters. So now let us go over all the distances that we have. We have the width of the hydro, which is 28.05. We're gonna increase it to 29 millimeters plus or minus 0.05 millimeters. The master cylinder bearing is about 22.3 millimeters. And when we do it, we're going to put a measurement of the holes. I took the measurement of the holes themselves, and the holes are 21.38 millimeters. So I realized that I had to actually punch the bottom pivot bearing out with just a socket and something light. And when I measured it, I got 21.38 millimeters. So we're going to put that, and this is when I start doing the machining, I need to put tolerances. Plus or minus, let's call it 0.01 millimeters, okay? The clip, which is the C clip, that's inside of the actual, I'm not sure if you can see that, so there we go. So the C clip sits right below the ridge. That was a width of 2.11 millimeters. And I actually need to take the thickness of that. So let's do that right now. So the thickness of the clip is 0.99 millimeters. I have my bearing width as 7.16 millimeters. And then I took the inside distance between these two holes right here. What I mean by inside is I simply took the distance from here to here. We got 16.08 millimeters. And the total length is of this. I wanted to add, it came out to 17 inches. I extended it to 20 inches, and we are at 508 millimeters. So with that, you're probably asking yourself, Ismail, do I need to be an engineer to do this kind of stuff? Do I need to go to school for 4 to 5 years to really figure this stuff out? Kind of. If you want to design your own car parts, start to get into, stuff like that, you really don't need to. What you should do is probably enroll in a CAD course of some kind, or maybe Creo, or maybe Fusion, or something like that. If you feel like you're a design-oriented type of person, there are free courses on YouTube that you can find. There are courses offered by these programs. I used Solid Professor through my college when I took my CAD course in order to learn how to use Creo Parametric and SolidWorks. Solid Professor was just for Solid Professor, and that's it. For Creo Parametrics, that was taught in class, but they also have a ton of videos for free on YouTube that'll teach you the basics of 3D design on your lap. My next step is to take this idea and bring it to reality. The whole point of this is to begin to design something on CAD that I can export into what's called G-code. And from there, I can send it off to a manufacturer to give me a 3D printed version of my entire kit. After I get that 3D printed version, I'm going to see if I need any revisions in my design. Once I make any type of revisions necessary, we're gonna go forth and we're going to finally head to the makerspace. I would go to the makerspace to 3D print it, but they don't have 3D printers large enough. But I'm gonna head over to the makerspace and I'm going to see what's the best block of aluminum or steel to use. So that's enough for today. On the next episode, we are going to design this on CAD. So if you like this video, like, subscribe, share for more. I've got so many ideas on what to do with this E30. So if you enjoyed this, follow me on TikTok, follow me on here, follow me on Instagram, like, subscribe, ring that notification bell, and I'll see you guys later. Peace out.
You're gonna upset me and you're gonna blow up your bumbuckler, pussy! And you're alone, you're gonna dead, Somebody else up there, so I'm gonna dead to pussy! You're gonna upset me and you're